Okay, so today we're going to look at the different types of motion that exist. So when we're looking at types of motion, what we have to look at first is our idea of distance versus displacement. So distance is looking at how far you travel regardless of the direction, and we call distance d, and we're always going to measure it in meters. So your standard metric unit. Okay, so when you're talking about distance, you're thinking about things like a pedometer that just counts your steps as you go. It just keeps adding them up throughout the day. Your car's odometer, again, they're just adding up those steps. It doesn't matter if you're going forwards, backwards, left, right. It's just constantly adding up those steps. Your displacement that we look at is either going to be X or Y, depending upon if you're talking in the horizontal or vertical direction, and we call that your change in your position. When you're looking at displacement, what you're looking at is you're looking at how far you are from your initial position. So the only two things that matter are where you started and where you end up. It doesn't matter what side trips you took along the way, it just matters where you started and where you ended up. So we call displacement, we use the letter delta a lot. Delta always means change. So anytime you see delta or your triangle in front of something, it always means change, which is always final minus initial. That means that your displacement can be positive or negative. Distance, on the other hand, since it's always additive, is always going to give you a positive number. Displacement is also, since it's a change in position, it's a distance, so it's also going to be measured in meters. So when you're looking at displacement, if you think about your day, where you start your day, okay, you start your school day in first period, you end your day in seventh period if it's an A day. If it's a B day, you start it in second period, you end it in eighth period. So we don't care about those in-between classes. We don't care what you have third or fifth. We don't care what you have fourth or sixth. All that matters is where you start and where you end. And then you find the distance between those 2 points as a straight line. So if you think about your regular day, you start your day in bed, you end your day in bed, and your displacement is 0. Okay, the next thing that we have to look at is this idea of velocity. Okay, you've heard the term velocity probably before, and it's a term that's often used improperly outside of physics. So there's a difference between speed and velocity. Speed is looking at the rate at which your distance changes, so it's going to be your distance over time. Okay, since distance doesn't depend upon direction, that means speed is also not going to be dependent upon direction. Time is going to be, anytime it says the rate, you're talking about something based on time. Time is always going to be measured in seconds, and so when you're looking at your speed, your unit is going to become meters per second. Okay, speed is always going to be positive, since distance has to be positive or 0, and time must always be positive. No one's going back in time. None of you have invented a time machine. So time will always be positive. So speed is always going to be a positive value. Again, always measured in meters per second. Speed is represented by the letter S. Your velocity then is looking at the rate that your displacement changes. Okay, so since your displacement can be positive or negative, that means your velocity can also be positive or negative. Okay, your speed and your velocity are not the same thing. Okay, just a regular example, when you're driving your car, you're going 65 miles per hour. That's your speed. Okay, your velocity then would be looking at, if you're driving on cruise control and you're just taking that time frame into it, your velocity would then be 65 miles per hour positive. Okay, that way you know you're going in a positive direction. Okay, if you were going west, you'd be losing ground, so then it would be negative. Okay, so your velocity can be either positive or negative, since displacement can be positive or negative. If you think about it, if you look on a graph, if you start at 0 and you go 4 meters to the west, then it would be 0 minus 4, 4 minus 0, and then you're looking at the fact that it's negative since you're going to the west. Okay, so again, your velocity can be positive or negative. Since displacement is measured in meters and time is measured in seconds, your unit for velocity is also meters per second. Neither of these two equations are on your formula sheet. When you look at your AP formula sheet, you'll see that there's a bunch of equations on there, but it's not all of them. Okay, so you're going to have to memorize some of them. Okay, you only get your formula sheet. No, you don't get to add anything on it for tests or quizzes or anything like that. You only get the equations that are on your formula sheet. So make sure you're looking at that, keeping in mind what is on the equation sheet and what is not, because these are not on there. Okay, the next thing that we look at is how we have to graph these things. So one of the most common graphs you're going to see is a distance or displacement versus time graph. Okay, what you'll notice is that your displacement is going to be on the y-axis, time is going to be on the x-axis. Okay, time is almost always on the x-axis, just because when we're looking at units, it's where you want it to be. Okay, so when in doubt, time goes on the x-axis. Okay, so displacement in meters goes on the vertical. If you're looking at a velocity versus time graph, again, time is going to be on your horizontal axis. Velocity is then going to be on your vertical axis. Okay, so what we're looking at with these is really looking at your slope of them. So whenever you make a graph in physics, don't think of it as, oh, I'm graphing this versus this. Why are you graphing that? Really look at what the slope means. Because in a lot of the AP problems that you're going to see, they're going to ask you questions, but what they're asking you to solve for is not necessarily on the graph. Okay, they want to see, can you interpret a graph? So one of the most common ways to interpret a graph is to find the slope. Okay, so remember your slope is rise over run, delta y over delta x, okay, or you can find it using y equals mx plus b. So if you look at your formula for velocity, okay, your slope, remember, is rise over run, velocity is displacement over time. If you look, okay, at a distance versus time graph, your slope would be your velocity. Okay, if you're looking again what's on the y-axis, your displacement, what's on the x-axis, your time. So anytime you're looking at a displacement versus time graph, your slope is the velocity. Okay, so if your slope is constant, that means your velocity is constant. If your slope is 0, that means your velocity is 0, so that means you're going in a straight line. If your slope is negative, that means you're going in a negative direction. Okay, you can also look at the steepness of the slope. The steeper the slope, the faster your velocity is. Okay, if your slope is curved, that means your slope is changing, which means your velocity is changing. If it's curved getting steeper, your velocity is increasing because your slope is increasing. If it's curved getting flatter, okay, then your slope is getting flatter, which means your velocity would be decreasing. Okay, so really paying attention to what your slope is telling you is going to tell you a lot about your motion. How are you moving and what ways are you moving? Okay, so if we look at this first example, okay, we have a displacement versus time graph. Okay, a couple different segments going on. Whenever you look at a displacement versus time graph, you always want to break it down into sections to where things are changing. So if you look, you have one thing going on till about 9 seconds, and then it changes. So you want to break that up into sections. So you'll go to about 9 seconds, describe that. Then you look, it goes to about 11 seconds, then it changes. So again, you're describing each segment. Every time your slope starts to have a different pattern to it, you want to stop and just describe that piece that you were just on. So from 0 to 9 seconds, you can look at it, and it is curving. Okay, and if you look at it, if you were to draw a line tangent to it, you would notice that your line is getting steeper and steeper and steeper, which means that your velocity is increasing. Okay, you don't know what it's increasing to. You could calculate it, find your slope, but I'm not looking for as much that numerical value. Okay, I want to know conceptually what is happening. With AP Physics 1, you will find out that the numbers, I expect you to use a calculator. If you can't use a calculator, okay, you shouldn't be in this class. Okay, what I want to know is conceptual. I want you to dive deeper and look at things. It's not just plug and chug. Okay, there's going to be a ton of conceptual stuff, okay, on here. The math should back up the conceptual. Okay, conceptual, math, they go hand in hand. You have to be able to do both. Okay, you can also look at your slope. It's also positive, so that tells you that you're moving in a positive direction. Okay, whenever we look at a graph, if you're moving away from the origin, that's going to be your positive direction. Okay, if you're moving towards the origin, it's going to be a negative direction. Okay, again, going back to your slope. If you look at from 9 to 11 seconds, you look at your slope, straight horizontal line, which means your slope is 0. Okay, so which means you're not moving. Okay, So you were speeding up, speeding up, speeding up, and then you come to an immediate stop. Okay, don't think of this as much so as like true to real life sometimes. So it's hard for you to like think about running and then coming to an immediate stop without slowing down, but that's what happened. Okay, we're not including any slowdown. You're literally running and then you stop instantaneously. Okay, then from 11 to 15 seconds, again, you're looking at that slope. You'll notice the slope is constant and positive. Okay, your slope isn't changing there, so that means you're moving at a constant speed, okay, or constant velocity. In this case, you could say constant velocity or constant speed because your direction is in the positive direction. That's your velocity. Still, your slope's not changing, so you're moving constant. Okay, so this is cruise control. Okay, again, we're ignoring the facts. So as soon as you started moving, you went at a constant pace. There's no speed up, there's no slow down. Whatever pace you took off at, as soon as you came out of that stopping point, that's what velocity you traveled with the entire time. Okay, and then from 15 to 17 seconds, you look at your slope. Your slope is now pointing down, so it's negative. So now you're moving backwards. You're moving in the negative direction, okay, and you're moving at a constant speed, okay. It's a really steep line, so that way it looks a little jagged because it's pixelated on the computer. But it is a straight line, so that tells you, again, you're going to be moving at a constant speed. Okay, if you look at what you described from 11 to 15 versus 15 to 7, in both places you use the word constant. Okay, constant just means not changing. You could add in 15 to 17 seconds that your speed, that numerical value that you're traveling at, is faster than 11 to 15 because it's much steeper. So you could say the speed is faster. But we don't know, okay? We're not calculating any numbers. All you're looking at is comparing the slopes, okay, between the two of them. That's it. Okay, so all of this you're getting just from looking at the graphs. Okay, I'm not talking about any numbers, no calculations yet, just conceptual. Okay, the next thing that you look at is with acceleration. Okay, so your acceleration is looking at the rate of change of velocity. Okay, so again, you're seeing the word rate of change. So already you know that time's going to be a factor in there. So it's something divided by time. And then you're looking at your velocity. Okay, your velocity, remembered, is in meters per second. So you're talking meters per second, which you can simplify to just simply say meters per second squared. Okay, acceleration is represented by the letter A. And again, velocity can be negative, so acceleration can be negative. Okay, so whatever it's based on is what you're looking at. You see the deltas again, so you're always talking final minus initial. Okay, it doesn't matter what delta is. Delta, whatever letter, always means final minus initial. Okay, every single time. That never, ever, ever changes. This equation is also not on your formula sheet, so another one that you're going to have to memorize. Okay, so when you're looking at your sign conventions, okay, your positive versus negatives are going to refer to directions, okay? So what I mentioned earlier about going west, west is negative. So if you're driving on I-10 heading east into town, it's positive. If you're driving on I-10 west, going out towards Katy, that's going to be a negative, okay? If you're driving on 45 north towards the Woodlands, that's in positive direction. If you're moving on 45 south, going towards Galveston, that's going to be a negative, okay? So positive and negative refers to direction, not increasing or decreasing amounts, okay? You can still be speeding up in the negative direction, okay? Because your slope could be negative, but your slope could be increasing, which means your velocity is increasing. So here's an easy way to tell. I would star this, circle it, highlight it, do something, memorize this slide. Okay, you are said to be speeding up if your velocity and acceleration have the same sign. So what that means is that if your acceleration is positive and you're accelerating in the north direction and your velocity is already in the north direction, means you're getting faster. Okay, the same thing is true if you're heading south. If you're accelerating in the southern direction and you're already moving in the southern direction, means you're getting faster, you're speeding up, okay? So you could think about it. If you are sliding in a rolling chair heading towards the right and someone else comes and pushes on you also to the right, okay, you're ready to traveling in the right, they're making you accelerate to the right, you're going to move faster. Okay, you are slowing down if they have opposite signs. So it doesn't matter which one is positive or negative. If they have opposite signs, you are going to be slowing down. Okay, so again, think about it. If you're traveling in the east direction, but your velocity changes in the negative direction, okay, that would be like hitting the brakes on I-10. So you're traveling east, so you're traveling into town, and then you hit the brakes. Okay, your brakes are a backwards motion on your car. So now your velocity is going positive, your acceleration is going negative, and you're going to slow down. Okay, same thing about gravity. Gravity always pulls everything down. So when you throw a ball up, it's moving up, but gravity's trying to pull it down, so the ball is going to slow down. Balls don't speed up on their way up when you throw them. Okay, they slow down. Okay, so this is an important thing, and you can get this literally right from the graph. Okay, look at your slope. What is your slope telling you? If your slope is positive, okay, then that's going to tell you a lot. So look at, be careful when you're looking at your signs, okay? Positive and negatives refer to direction, not increasing and decreasing, okay? And that's a common thing in physics, which you're going to see a lot. Okay, so again, your acceleration, you can have the same thing, rise over run. So when you're looking at a velocity versus time graph, that means that your slope would be your acceleration. So in order to compare the two to find out if you're, in this case, if you look at it, your velocity is in the positive direction, you're above the x-axis. Your acceleration has a positive slope, so that means you are speeding up. Because your acceleration's positive, because your slope's positive, you're above the x-axis, so that means your velocity is positive, so you are speeding up. Okay, because they're both positive when you're looking at it. Again, time is always on the y-axis, or on the x-axis, excuse me. Time is always on the x-axis. Okay, so here are 3 different graphs that you can look at. Okay, these 3 graphs, I would draw them. They are actually all the same thing, situation that's happening. So here you have your displacement versus time graph. You'll see it as displacement versus time, distance versus time, position versus time. They're all talking about that same thing measured in meters. So if you look at your position, you're moving in the positive direction because you're moving away from the origin. But if you look at your slope starts out really steep and then gets flatter and flatter and flatter and flatter. So your slope is changing, which means your velocity is changing, but your slope is getting flatter, which means your velocity is decreasing. Okay, which takes us then to our velocity versus time graph. So if you look at it, your slope is really steep here, so that means you're starting out with a high velocity. And then down here, your slope is almost 0, so that means at the end of the time, your velocity is almost at 0. Okay, and then you just connect them between there, so your velocity is decreasing, 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 decreasing. Okay, you'll sometimes see this as meters per second to the -1. That -1 is telling you that it's meters per second. Seconds should be in the denominator. Then if you take the slope of this line, okay, that would tell you your acceleration. So if you look at your slope is constant, but it's negative, so that tells you that you have a negative acceleration. Okay, again, look at it. You have a negative acceleration, but you're moving in the positive direction. Okay, this right here is not telling you anything about what's happening to your speed as far as where you're going. It's literally just telling you that you are slowing down, okay, as you look at it. So be careful with the graphs. All right, so next thing you can do is when you're finding your displacement, okay, if you think you have your velocity equation, displacement over time, so displacement would be t times v. If you look at that, you're multiplying 2 numbers, that would be the same thing as finding your area. So you can have your time would be your base, your height would be your velocity, this on a velocity versus time graph, so your x would be your area. Okay, so if you look at it from this perspective on this graph, you have a velocity versus time graph. Okay, and if you want to find your displacement is looking at your distance or how far you're traveling. Okay, this is like my side pet peeve. Okay, Houstonians have a horrible habit of when someone says how far something is, you answer in time. Far is a distance. How far did you travel is miles. It's meters. It's kilometers. Okay. Far is a distance, not time. Okay. I understand that living in Houston, if you tell someone that something is 5 miles away, it may take you 20 minutes to get there. Okay, I understand that. From Ohio, and I didn't get that for a long time. From like a teeny tiny town that literally has 2 stoplights. Okay, so for me, when someone would say that it's 20 minutes away, I expected 20 miles. Okay, because that's what I'm used to. There's not like any traffic in my hometown unless you get stuck behind a tractor. So far is a distance. I want a unit of meters. So if I look at how far I traveled during A, okay, I'm looking for my distance or my displacement, so I'm going to find the area of A. So A is a triangle, so I'm going to do 1/2 base times height. So 1/2 10 times 20 is going to give me 100. Okay, if I want to know how far I traveled during B, now I have a square, so it's base times height. 20 times 20 is going to give me 400. And then I could do the same thing for C. 1/2 base times height, okay, which is going to give me 400. If you look at all of these, your velocity is positive, okay? That means that I'm always moving in the positive direction. Even though my velocity is slowing down during section C, I am still moving in the positive direction because I am not below the x-axis. Okay, remember, positives and negatives refer to directions, okay? So during A, I'm speeding up in the positive direction because my slope is going to be positive. Okay, during B, I'm moving at a constant velocity. C, I'm slowing down in the positive direction. Okay, so if you look at C, my slope would be negative. So that means my acceleration is negative, but the numerical values of my velocity are positive. So I have positive velocity, negative acceleration, which tells me that I'm slowing down. Okay, my location on the graph, being that I'm above the x-axis, tells me I'm still positive. If you are moving west, if you are moving south, then these triangles or the box would be flipped below the x-axis. Okay, so if you're above the x-axis, that means you're in the positive direction. Below the x-axis, you're in the negative direction. If you wanted to figure out how far you moved during this total time, you would just add those up. 100 plus 400 plus 400, which would give you 900. If something was flipped below the x-axis and it was negative and I wanted to know my displacement, I would have to make sure I subtract that part out because it would be negative. If I wanted to know my distance during the whole thing, I would just add everything up. Remember, distance is always positive. Displacement looks at the positive and negatives. All right. This slide, I think, is one of my favorites that you're going to see, okay? And it is literally telling you what type of graph you have and how you get to the other one. So if you have a position versus time graph and you want to find your slope of that, that's okay. That's going to give you your velocity. So anytime you have a position versus time graph, if you find your slope, you're finding your velocity, okay? If you find the area of it, it's nothing. Okay, nothing we'll ever worry about. If you have a velocity versus time graph and you go to find your slope, that's going to give you your acceleration. Okay, so again, you'd be taking velocity over time, which is acceleration. Okay, that would be your slope. If you find your area, then it would be velocity times time, which would give you meters, so that's going to tell you your displacement. So if you have a velocity versus time graph, you can find your acceleration or your displacement. Okay, this middle graphic just shows you it in a different manner. So here you have your position versus time graph. It just shows you your slope is your velocity. If you have a velocity versus time graph, your slope is your acceleration. Your area would be your displacement. If you ever had an acceleration versus time graph, I've seen it on a few AP tests, again, conceptual. If you have an acceleration versus time graph, if you find the area on an acceleration versus time graph, it'd be acceleration times time, which would give you velocity. So acceleration times time graph, your area would be your acceleration. Your slope would actually be the jerk factor. And the jerk is looking at the rate that your acceleration changes. The jerk factor is actually what causes whiplash. because your body accelerates forward and then it accelerates back, and they're looking at the acceleration of your head forward and then your head backwards, and that's what causes that whiplash, that pain in your neck. Roller coasters. I'm an avid roller coaster junkie. I haven't met a roller coaster I won't ride or that I don't like, except for unless it's lame. Okay, they haven't made one fast enough or tall enough for me yet. If you know anything about Ohio, Cedar Point, roller coaster capital of the world, and I used to have a season pass there. Okay, so I'd go there every year, multiple times. And on the roller coasters, they have to worry about the jerk factor. As you're making a curve, as you're going down a hill, how fast is your body going to be accelerating to make sure it's not putting too much pain on your neck or on your joints. Again, they don't want to give you whiplash when you get off a roller coaster. Okay, and then this bottom graphic just shows the same thing. If you want to have a position versus time graph and you find your slope, it's going to give you your velocity. If you have a velocity versus time graph and you find your area, it's going to give you your displacement. So it's just different ways showing you the same thing, but it's so important for you to know how to interpret these graphs. Okay, so what I want y'all to do is get on the computer. You're going to go to this website. Sorry for all you Google Chrome users. This will not run in Chrome. You have to run it in Internet Explorer or Firefox. Sorry, I apologize, just the way it's ran. So you're going to have to run this. I don't think it'll play on your cell phone. So you're going to get a computer. You're going to go to this website. I think I have it pulled up. So you're going to type it in, go to this website, and it says you're going to hit the button that says click to activate the physics. And it's going to play some horrible music. Okay, and it's this graphing challenge, and you're just going to play a bunch of different levels. Okay, so what you have to do is figure out how to make the objects move to create the graph below. So this is a way for you to see how position and velocities are related on a graph and how you actually physically move to create them. So not only do you have to be able to interpret these graphs, but you have to understand how you move to produce them. So like we did with that displacement graph where we said you're moving in the positive direction, constantly increasing speed, decreasing speed. The same thing. So go through this, play a bunch of levels as much as you can. Just have fun with it just to get good practice. Who knows, some of these might show up on a test or on a quiz. You never know. The only bad thing is that every time you log into a computer, you do have to start over from level 1. So if you play it on your own when you're at home, just you want to study for the test or something to practice these, if the first time you log in, you will have to start back at level 1. Okay, once you've logged in a few times and you've done it, it'll save your spot, which is nice. So if you're on your personal computer and you get to like level 10, you can just start over at level 10 each time. You don't have to go back. Okay, so that is it for this lesson.